Okay, good morning. It is day 9 of coding every day until I get a job. It's kind of funny that I named this coding every day until I get a job. And yet, since the start of this, I think I've applied to 5 jobs, or internships. I should say internships, but whatever. Um, so I need to get on that. I should do a lot tonight. Um, See, it's just the only thing is most of my time has been taken up with finals these last like since Thanksgiving break. Um, so so yeah. What did I want to say? Again, I have the 3D printer going. I don't know if it's gonna work this time. In last video, if you watched, I had to just stop it. I kept pausing and pausing and pausing to check and restart it and restart it and fix it. And this one already kind of fucked up, but I'm gonna see if it's like or fixed itself. There's something weird with the bed leveling. I don't know if I'm gonna have to put like a piece of paper underneath um underneath the bed, but like all of a sudden it's just not level anymore. Um so and I've done like a leveling print and I just can't get it right. So might have to pause this again and literally take 20 minutes to try to fix the printer and try the leveling thing again. Um, and then if I can't get this thing going by noon, I probably just stop the print and then use the school's printers. So, um, what else? What else before I start planning out the day? Um, I think that's it. I don't think there's anything else I really want to talk about other than what I want to do today and this week, I guess. Kind of. I don't know. Okay, plan for deep work. One thing I want to say um, is yesterday was really not. It wasn't deep work, right? Like I should close this. Um, um, I was like pausing, getting up, going back and forth, like all that. Deep work is I sit at my computer and I focus on something for like hours at a time. Nothing, no distraction, no nothing. So I need to make sure I'm doing that, or else this just becomes not deep work and I won't be getting as much done in the time that I'm spending. So, so obviously every day until it's done, I'll do our admin of code. Uh, Day number 8. And then I want to, I didn't actually, I said review these sections today and then finish these today. I didn't. So it's going to be today, I'm going to review sections 29 through 39 of um, my comp sci 250 class. Um, for this, what I usually do is I just control A the slides and put it in ChatGPT and ask it to summarize. And as it's doing that, I'll like go through the slides and just like try to figure out what's going on. Um, and then go through the summarization and add any notes that I want to add. And so this way, I mean, I only have 5 days until the final. And so this way, I'm just gonna get like a good kind of understanding of not a good understanding, just like a general understanding of what's going on. Like if someone were to ask me a question, like on what it is, I'd be able to say what it is, but I wouldn't be able to solve the problem yet, right? So that's the idea of the reviewing these sections. And then I'm going to get together homework questions, quizzes, discussions, all that, put it all together, and tonight I'll do that. And then Monday, Tuesday, Wednesday, Thursday, I'm just going to do the past exams, the past homeworks and quizzes and all that. So this week, these up until Thursday, mm, these videos will probably be advent of code, discrete math study, maybe a leak code at the end. But I don't really care about leak code right now. I want to focus on making sure I get a good grade on this final. Um, um, and then maybe one elite code, depending how fast I can get through this. Which I mean, it should take like 20 minutes a pop. So that's, I mean, if we have to go through 10 sections and it's gonna take 20 minutes, that means it's going to take over 3 hours to get through that. So we'll see. And I have a meeting at 3, but I mean I can just pause for that and then come back. So we'll see. Day number 8. Why did it do that? EOM. Give me day 8. It's not gonna be here. I shouldn't have done this. What I want to do is I want to CD into downloads. CD into downloads. CD into advent of code. CD into day 8. And then I want to echo. Was it echo period? Data dot text. No, just that. Oh. And then also echo period. Day 8 dot py. Okay, so now both of these should be in there, and I should be able to now say day 8 dot text. Oh my god, I messed that up. How do I delete? I'll just go into here. Ba, 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 ba. Actually, I should look this up just for like future reference. How do I delete a file from terminal? Okay. So what even, just remove item? Data dot remove item is not recognized. Ugh. Oh wow. Well, that's just fucking easy. Okay. Data dot text. Oh. Okay. We're good now. Give me that. I'm gonna check on 3D print real quick because it's moving a lot. God, it's like it's like on the front side of the 3D printer, on like edges, it's just messing up. But it makes no. It's. I have it really close to the ground. I mean, I guess I have to. It's so weird because it's like if I raise it anymore, then when it like makes a sharp turn, it just drags the piece with it because it's not down enough. But if it's like, when I put it like really close down, it's like messing up corners. I think that still means I need to put it down more. I don't know. Hopefully this pulls through. Um, and then I wanted, what, day 8.py. Okay. You find yourself on the roof of a top secret Easter Bunny installation. While the historians do their thing, you must take a look at the familiar huge antenna. Much to your surprise, it seems to have been reconfigured to emit a signal that makes people 0.1% more likely to buy Easter Bunny brand imitation mediocre chocolate as a Christmas gift. Unthinkable. Scanning across the city, you find that there are actually many of these antennas. Each antenna is tuned to a specific frequency indicated by a single lowercase letter, uppercase letter, or digit. You create a map of these antennas. Okay. The signal only applies its effect at specific antinodes based on the resonant frequencies of the antennas. In particular, an antinode occurs at any point that is perfectly in line with two antennas with the same frequency. Wait. Okay. The signal only applies. It's the fairy's effect at specific antinodes based on the resonant frequencies of the antennas. In particular, it occurs at any point that is perfectly in line with the two antennas at the same frequency, but only when one of the antennas is twice as far away as the other. Okay, this means that for any pair of antennas with the same frequency, there are two antinodes on either side of them. So these two antennas with the frequency A, they create this. Okay. Adding a third. What? Adding up a third antenna creates several more. It would ideally add four, but two are off the right side. Antennas with different frequencies don't create antennas. And okay, I'm back. Sorry, um my dad needed me for something, so we back. By the way, this is now like I have to pause a lot in these videos because my parents just come in a lot because I'm still living at home. And on January 1st, I'm moving out. So, which reminds me, I actually have to send an email to the guy I'm taking over the lease of to get the key. But I'm moving out, so it's gonna be so nice. Like January 1st, I can actually get deep work done. Like I can actually like wake up, start recording, no sounds, no nothing. I could do 3D prints at the school because it's 5 minutes away. So I'm not gonna bring my 3D printer with me. So you'll never hear this. It'll just be nice and silent, and I can just get work done. So we have 22 more days of this, of, probably having to pause many times a video. But yeah. Um, so as I was walking around, still have no idea what this problem's fucking asking. I'll be honest. Like, so okay, so we have these nodes. Let me look at the whole input. So it's just a bunch of different letters and numbers. So the first example has antennas with two different frequencies. So we have an A and a capital A antenna. So the antenna nodes look like this, plus the antenna node overlapping. So, okay, okay. So the first example we had was an A, and these four zeros, right? So, because the top was A frequency antenna overlaps with the zero frequency, this one, no, that's an overlap. If it was, you took a look at the familiar, with much to your surprise, it seems to have been scanning across the city, you find that there are actually many antennas. Each antenna is tuned to a specific frequency indicated by a single lowercase letter, uppercase letter, or digit. So these are also, I'm going to ask ChatGPT not to solve this, but I need to ask some clarifying questions here. Okay, give me a new, fresh O1 mini. Given this problem, do not solve it, but just answer my questions for clarity. In that first example, is all is both the zeros, A's and A's, all antennas? Also, I have more questions. Actually, that first one we just have capital A's. The signal only applies its effects at specific nodes based on resonant frequencies of the antennas. In particular, an antinode occurs at any point that is perfectly in line with two antennas. So I'd assume that these are perfectly in line, like diagonally. I'd assume these aren't perfectly in line. I'd assume this isn't in line with anything. I'd assume the only things in line are like these and these, right? An antinode occurs at any point that is perfectly in line with two antennas of the same frequency. So these are the only ones, right? But only when one of the antennas is twice as far away as the other. Okay, so for these two antennas, right, with the frequency A, they create two antinodes. So the distance between these is 2, right? So the distance between this and this has to be 4. So 1, 2, 3, 4. 1, 2, 3, 4, right? But this being a line is crazy. You're saying this is a line? I'd assume a line would be the A is like here or the A is here. How is this a line when it goes down one, over one? I guess down one, over one, down one. Wait, no. Because if I go down one from there, right, and I go over one, then I go down one, over one, down one, over one. Now we're just off a line, right? I'd assume it'd be like bam, 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 right? But I guess not. Actually, wait. This is at the fourth spot. So if I wanted to be in line, this one would be in the fifth. But then that one would have to be in the sixth. Yeah, I don't get this whole line thing. Adding a third antenna with the same frequency, so it would be, yeah. Oh, I see. There'd be one over here, but it just goes off the map. So it's a bounds checker. Okay. I understand this whole thing of like the distance between here and here needs to be the distance between here. Or no. The distance between there and there needs to be twice the length to the antenna node, right? I just don't get this whole line thing. It's so hard to say like what a line is here. And so different frequencies don't create. So here, and they count as different frequencies, however, the antennas can occur. Wait, so when it says but it has this frequency, does that mean it makes the frequency even though there's something there? Antinodes can occur at locations that contain antennas. Okay. So it means that like you can create something that overlaps something, right? Okay. Advent of code day 8 part number 1. I kind of want to parse this like as we were doing yesterday. Was it yesterday? There was definitely uh um not yesterday. Day 6 maybe? Yeah. It was something like this. Uh I'll just yank this for now. So open with data.text as city. Um, I won't enumerate for now. For I'll just say line in city. Um, I guess path line is fine. For line in city, path line equals this. Actually, you know what? First strip in city. Strip line empty for strip. No, for um block in strip.strip. um if this is equal to that, append a 1. Input should have no hashtags, right? Yeah. So there's no hashtags in here. So I don't have to do this. Else just append what it is, right? Else I just want to append um so we'll have our city map. So this will be a city map dot append strip line. Right? Oh, actually, this can be anything. So maybe I do just keep this as a period, which this is now inefficient, but whatever. Python. Wait, I don't even have a print statement. So what am I doing? For line in city map. Print line. Oh, my bad. If block. Okay, beautiful. I'm gonna use the bathroom real quick. I'll be right back. Where were we? Okay, so I want to look at this. So these all have the same frequency, right? So this has one, 2, 3 away, right? So 6 away. So 1, 2, 3, 4, 5, 6, I guess. So it makes sense for that one. This one makes sense. This one makes sense. This one makes sense. This one makes sense. Wouldn't there be one for this? There would, and it's on the A, and then one's off. And then there's one for this, which is this and this. Oh, yeah, I see what's happening. The only thing is the whole like straight line part. How are these straight lines? This one makes sense, right? This makes sense as a straight line. But this being a straight line, I guess it's just trying to say like, oh, you know what? It's just trying to say a straight line is between any two antennas. It's not like it's a global one by one step. It could be a two by one step, but it's a two by one step because it's a two by one step here. Like, so I'm assuming, let's go to this big puzzle input for a second. If we were to look at the D here, give me another D somewhere. And the D here, are we saying that this is a line from here to here? So there'd be one over here and one over here? I think it is saying that, right? Oh my God, ChatGPT using inline quotes. Okay, so I've moved past this misunderstanding. I know this. This is so perfectly in line. What does perfectly in line mean? You'd think it means on this or on this, but I think it means anywhere, right? I just have one more clarification question before I can solve this. And it's, whoa. How fast is that? What the fuck? Um, a perfectly straight line between 2 points on a grid means that all points along the line follow consistent direction without any deviation. Yeah, so it just means, but you can make a straight line between any 2 points. There's no 2 points in the world that can't be connected via a straight line unless we're dealing with like um no. I mean, I guess you could say unless we're outside of a three-dimensional space, but like even on like it's so stupid. I don't even, but like, even on Earth, that there's two dots like that we're trying to connect. It's not like we have to like bend we can just go straight through, right? It's just you make a straight line at any 2 points. So it doesn't matter they're offset or anything. But if you want to connect 3 lines, right? That's probably part two. Part two of this is probably the perfectly straight line actually needs to be perfectly straight. Right now, it's you just okay. Okay, I see. I understand it now. So the whole idea is we're just going to go through, and if we find any point in which is not a period, we are going to capture that, and we're just going to start like going through and looking for like it's basically going to be go through, find this, in that like outside loop stays on this as it goes through an inside loop and it goes through and it's like, okay, let's go find something that is similar to this, right? Once it finds a similar node, it's going to just calculate the distance and then it's going to make a antenna. The only thing I want to know, if two antennas that are different have an antinode on the same point, is that two antinodes or just one? If two antennas of different frequency generated on the same point is considered a single unique antinode location. Oh, is that what they want? Unique locations within the bounds of the map contain an antinode. Okay. So I could even I think the best way to approach this would be, like I said, to go through this, like go through, okay, we go through the whole first line, we found nothing. We go through the second line, oh, we found a 0. So now we call a function that passes through this antenna type and it goes through until it finds the first instance of that and then it takes the two coordinates, calculates the distance and then places a node, like finds that in there and changes it from a period to a hashtag, right? And then um and we just go and then we stay, we don't exit this, we keep going, right, until we find another occurrence and we just keep exhausting that until we've placed all our hashtags and then that outside loop moves on and it's like, oh, we found this one, let's go and let's check every single thing. um and actually you might think, and there's no like, because it's only unique ones, even if I'm not thinking of something right now that would end up like repeating stuff, it's fine. Repeating stuff is fine. But like my idea is on the first one, we draw this hashtag that would go like over here, just eyeballing it, right? Somewhere over here for these two. And then when I go through again and I look at this, right? I'm going to find this one and I'm just going to actually just go through the whole thing again and go look for the first occurrence. And I'm like, oh, I found this one. So I'll place this one out here. And then I find this one, I go through and I'm like, oh, I found this one. This one's out of bounds, right? So this should actually, the logic here, I understand completely now. It's more so, how am I going to pull this off? So first, obviously, we just need to loop through this, right? We just need to honestly just remove this print line and just say, actually, I kind of like that print line. I kind of like it. Actually, I'll remove it. So for each line in the city map, I want to check if, no, 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 no. Oh yeah, no, no, no. I want to do a for now block inline. I want to say, okay, if block is is not a period, right? Then I want to call a function, right? Which we're gonna call what? It needs to be something that is now going to pretty much recall this whole thing, but it's going to so we want it to pass through the antenna type and the antenna coordinate, right? So these are going to end up being enumerates because I need to pass through a coordinate. So line and actually, is it the value comes first? I actually can see right here. Ah, line index and block index. So the idea is we're going to find antonym. And so we're going to pass through the city map or just the map, the city. We're going to pass through the city. We're going to pass through the type, a type, the X and the Y, right? Because I want to pass through the current state of the map, the current type we're checking for, and the coordinates of the node that we are trying to find all of its, connections for. So this is just trying to find all of those. So we're saying, okay, if when we're going through, if it's not a period, then I want to call finance node, and I want to pass through city map, city map, block, and then um, block index and line index. Right, right. Pretty sure. And so what are we returning here? I don't really think we are returning anything. We just want to update city map at the end of this with all the new. The only thing I'm thinking of right now is like if so like for this, I originally passed through city map, right? If I were to change city map in here, I don't think city map would change here, right? Hey, that's a really good question. If I were passing a 2D array if I was going through a 2D array as a double for loop, and within the inner loop called a function that changed that 2D array, would the for loop change, or would it still loop based off of the old 2D array? For example, also, don't give me any code or solve this advent of code question. Just my question. Okay, I see. I see. So will this ever be an issue then? I'm trying to think. Would this ever be an issue of directly, like, should I have, I mean, I guess it's probably just good practice, right? Of, like, if I said right here, if I said that, like, um I don't know, if I said node map equals city map, right? And then I went through and I print off node map, or for line in node map print line, should be the exact same thing, right? Oh, it's because I need to return none. Yeah, same thing. Same thing, same thing. Okay, so yeah, I mean I should just do that, right? So now this is just gonna go through. It's just to make sure it's safe. So yeah. So is there anything else this is ever going to do? I just want to make sure this. So if it's not a period, right, then it's an antenna. Actually, this is really good. This is where it would have broke, because once I start putting hashtags in, if I was still doing the thing on the hashtags, um, then it would have found a hashtag and it would have broke because there's no else. So yeah. So I call this with city map. Our current node and our current type of whatever. And so in here, what I want to do is I want to take the block type, right? And I want to see if anything matches it. So I mean, it's going to be another for loop. It should just be literally this exact same thing, right? I'm pretty sure. Right, where we're saying, let's loop through here again. But if I run into, if line and block index do not equal x and y, so this is kind of a big if statement, right? Because I'm saying, okay, if the line index is not y and the block index is not x, and the block is equal to this, right? Then print block. Syntax warning. I thought this is not legal in Python, is what it told me yesterday. Okay. Yeah, and so it just prints off 0, 0, 0, 0, 0, zeros and A's. So it's just printing off. So like it's finding. Maybe sure this is. So the logic here would be it finds one, and then it goes through the whole thing, and it should print off. Okay, let's go up here. This is the example I'm passing through. So it should find this one, and it should go print those three. So 3, 3, 3, right? It should print off 12 of those. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Perfect. Perfect. So so now what do we want to do with this? We want to take the original x and y, and when we get to this point, we want to figure out new coordinates and then take node map at those coordinates and change it to a hashtag. So it should be, okay, we found something from here. We want to find the distance. So distance is going to be equal to well, we have the x and y's for both, right? ChatGPT actually gave this a while back, which is distance between but can I just take the distance? I'm trying to think how I can easily just take the distance here. I mean, here, for instance, let's print off um, original node x, y, and then also print off new node line index block index. Sorry, father came in again. Okay, block index and line index. Okay, let's get the 5,000 prints. 8, 1. So this is 8 across, 1 down. And then this is 5, 2. So the distance between this is 1, 2. Right? No, that's 3. Right? 1, 2, 3. Pretty sure that's 3. So it's just, so if it's 3, it's just these two minus. What about between this one and this one? Obviously, that's also 3. But that's the thing, is it's like, how can I like dynamically like make sure? I guess it's just always the positive, right? Because I mean, I get -3, but we'll just take the positive of that, right? And then we go to this node, right? The this one, and then we have 8, 1, and so this is 1. Is this 2 away? 1, 2. So if that's 2 away, right? Which one was that again? It was this one, yeah. And that's the y's minus each other. So this like gets interesting because it's like this one I was looking at horizontally. But can we look at them all vertically? No. Because then you'd be saying that this is 1 away when it's not 1 away. Let me ask ChatGPT because it is probably just a math equation. How do I find the distance between all these nodes with one clean equation? Isn't the whole like y1 minus y2 over x1 minus x2 or something like that? Um, I don't care about training your fucking model, bro. How long have I been live? Live. Hour. I'm gonna pause and check 3D print while this response is generating, which it doesn't even look like it's generating, but I mean, like it's looking better. But I have this little like Doyle thing, um, and it completely bunched up. So now, now every time it goes over there, it's gonna be too high, and it's just all gonna go everywhere. Hopefully, it detaches before it goes to another part. But ChatGPT loaded, so that's nice. Understand the distance count. When working with coordinates in a 2D grid, such as your nodes, calculating the distance between 2 points is a fundamental operation. Use the Euclidean distance formula, which is x2 minus blah, 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 blah. Difference in x, difference in y, square both the differences, sum that, and then get the square root. This formula ensures, regardless of direction or orientation of the 2 points, you obtain the accurate straight line distance. Cool. Okay, so to find distance here, I'm going to, I like this one better because it gives me a little code snippet. A little more. Okay. So we're going to say um, the distance is equal to the square root between, so x2, x2, which is the second node, which is going to be the block index. The block index minus x1, which is going to be x. I forgot. Star star 2 is how you square root. Not square root, power of 2 something. Or you could do power of, right? P, is it just PWR? And you put through the two arguments of like block index minus that, comma, but this just seems simpler. Plus the line index minus y squared, right? Print distance. Um, Square root is not defined. Is it like math? Like import math? Um, import square root Python. Import math. Oh my god, I literally just had it. Am I the goat? What is he talking about? What is you talking about? Square root. All of this. Oh, maybe it's because I need to do an npm. Do I really not have math as just like a global? What do you mean square root is not defined? From numpy, import math. No module name numpy. The fuck do you mean there's no module? Oh, import numpy as np, and then do an np dot square root. Oh, import. What the fuck? Why is math not working? Oh, wait, pip install numpy. Oh. Finally, bro. Okay. But these are giving very fucking weird distances. Um, ABS. Give me that ABS. Okay. Um, how to ha ha ha. Okay. And then let's make sure. So like this one, 1, 2, 3. 1, 2. Then 1, 2, 3. 5. 5. 1, 2, 3. 5. Okay, let's call it 5, I guess. I could see. The only thing is, it's like, okay, if I could go here, 1, 2, 3, 4. But if I go like 1, 2, 3, 4, 5, it's like, okay, I could get there in 5. But like, can I really not just do this? That would be 4. Another interruption. Another. Just to never lock in. Okay. Let's assume that this is just correct. Okay. Um, so now we have the distance. So now we have to take this distance. And we have to place this on the straight line, which would mean, so like this first one I said is 2, right? Or is it 3? Okay, it's 3. Beautiful. 1, 2, don't get it. Wait, I actually don't get it. How is that? I guess 1, 2, 3, down 1, just minus that. I guess. Sure, right? Over 3, down 1, call it 3. How am I going to figure this out? I need to figure out the x and the y change to get to there. Going back to distance, is there a way instead of just the distance, I can find the change in x and y between the two? Right? Because if I can find this, so first I want to like validify the distance when making the next thing. Actually, no, I don't even have to do. Like, I don't think I need this because I don't have to validify. Whoa. Delta x and delta y. Delta x is equal to the new x minus the original x. This is it. If I found out that this is 3, -1, right? Then on the next one, I want to plot it at 3, -1, like from that node. So again, I don't think I need this distance. I think all I need to do is say x delta is equal to new x, which is the block index, minus x. And then the y delta is equal to the line index minus y. Okay. And then I want to say, actually, when I pass this through, I think I want to pass through node map and like just declare this as like a global node map. And so this way I could say Actually, can't I like do like node map equals the result of this, and I'm gonna end up just returning the city? I think that would actually be pretty good. So, city at, well, actually, these are new node. Actually, new node X is going to be. So this is just taking the difference between them, right? So if block index, yeah, this is just taking the difference. What I want to do now is add this to the new one. No. At the new one, right? Which is the, like, the X would be the block index, right? But I now want to add whatever the X delta is. So if the X delta is negative, then it's going to go back. If it's positive, it's going to go forward. And then the new node Y is equal to the line index plus Y delta. So city is going to be equal to, wait, no, well, city at new node Y, new node X is going to be equal to this. Give me errors. Can I just do that? I mean, invalid syntax. Do not solve the question or code, just what I am asking right now. How do I make it so that the node map is a copy of city map and the find antinode function returns the updated node map and updates it globally? Bro, like, I hate when it does this because now it's like I was going to forget to check bounds on this, but now it just literally gave me the fucking code. Oh my god. You just gave me code for stuff outside the fucking question. Do not give me any code outside of just updating it globally. Also, it is not a linked list, it's just an array. That's so annoying, bro. So annoying. Okay, dude, I'll import copy. What then is this? I don't think that this works though. Bounds checking. If what's the bounds going to be? What's the bounds going to be? I mean, I just have to make sure that it's not like as long as the new node X, if new node X is either less than or equal to 0, or I guess I should say is greater than or equal to 0, and new node X is less than what? The length of line. And new node Y is greater than or equal to 0. I mean, it's the same bounds checking for both, right? It just can't be less than 0 um and it's less than city map, the length of city map. Oh, my bad. I mean invalid. Oh, what did he do on this? If oh yeah, I can't just do that. True that. Just if 0. I mean, it's the same thing I just did. If the new node Y is greater than or equal to 0, but it is less than the length of the city. Yeah. And 0 less than or equal to new node x, which is this length of line. Okay, cool. And then print node map. Oh shit. Except I want to for line in node map. Print the line. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14. So that's just the extent of the logic here. Neovim bam data.txt. I'm gonna have to scroll through a lot of these. 8. Let's see. I doubt this works. I'm honest, I'm just mad it gave me the fucking bounce shit. That's so sad. Because I would have definitely forgot to do it. Oh yeah, I just need a loop to go through and count. Actually, I can undo and just for line in this if, actually no, if for line and then for block in line, if block equals hashtag return count, or I'll call it anti-nodes. Then anti-nodes plus equals 1. And then this should just be print off. Three, 3, 2. Wow. I don't know actually what I mean. Like this was all except for obviously checking me on making sure I check bounds. I mean, I did the bounds by myself anyways. It was just a reminder. And then just setting up global. I mean, the actual logic of all this, I truthfully did all by myself. So that's really nice. This was easier than yesterday. This part 1. It is nice that I've been like consistently getting this part 1 done by myself. So, um, I like this. This was actually, I think, a pretty efficient way to do this. I don't actually know what would be a more efficient way of doing this. I don't know. I'm gonna check my print real quick, and then we'll do part 2. Bro, it's so funny, this print. Like I said, it like messed up the first like layer of which I wonder, is it because I just didn't put it on the ground or something? Yeah. Like look at this. Every single one on this first layer is getting put down, and this one isn't. And on the second layer, it only starts on this one. And I think it's literally because it's just like not on the ground. So I don't know. So literally what's happening is this part just keeps trying to like print the next layer. And so then it goes to a different part. Whatever. Okay. Time for part two. Part two. Okay. Watching over your shoulder as you work, one of the historians asked if you took the effects of the resonant harmonics into your calculations. Whoops. After updating your model, it turns out that the antennode occurs at any grid position exactly in line with at least two antennas of the same position, same frequency, regardless of distance. This means that some of the new antennodes will occur at a position of each antenna. Unless the antenna is the only one of its frequency. Wait, so what was it? It turns out that an antennode occurs at any grid position exactly in line with at least two antennas of the same frequency, regardless of distance. In fact, the 3T are exactly in line with two antennas. So they are all antinodes. This brings the total antennas in the above example to 9. Wait, what's changing here? I don't get it. It's instead of just at the distance, it's at that distance repeating. Is that it? It's just at that distance and it just keeps repeating. So I mean, what stops that right now? It's just because I'm looking at. So instead of just making the new coordinate, I take the delta and I repeatedly do it until out of bounds. That should be it, right? This should be quite easy then, right? All this is instead of I find x delta and y delta, and then I find those two nodes, and then I'm just adding it on, it'll be like I'll do this. So like this will be like a while this. So like wait, actually sorry. I still want this. But now, well no, actually. Actually yeah, okay, Jesus. This will be the initial one. And then in here I want to update these so it's that the new node at x plus equals. Well, okay, wait. This needs to go before this. But then it's just the new node plus equal the delta x. And new node y plus equal y delta, right? And it just keeps going through and it just adds and adds and adds. Is that all? Too low. Okay, let's go back to this, and then I also want to print off not just adding this. Oh, wait. I want to print. 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 Oh, wait. I want to print Print line. Jesus. Print line. 29. And what is it here? From just my like naked eye looking at this, it looks like I'm like finding everything. Wait, which ones am I missing? I don't think it's actually that I'm missing. I think it's that these 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 20. 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. Okay, it is changing those antennas to stars. The only thing I could think of is what am I passing through? I'm passing through city, which is node map. But should I be passing through city map? Doesn't change anything. Doesn't change anything. But I'm missing like this A is now correct. Wait, how is passing through so confused? How is it possible I'm getting the same answer on both of these? But this one is now like missing like here or like here or here, right? Which is like I need these. But then it is actually overtaking. Like all of these that I wanted to overtake. So like here it overlaps everything but 1A, right? So here in my 29, it means that 1, 2, 3, 4 would be added to this. Wait, no. Yeah, 1, 2, 3, 4 more would be added to this, which would give me 33. Oh, brother. What is going on? Let me look at this one. So like if I look at this one for an input, no, not what I wanted to do. Right? And I replaced all of these with this. Does this algorithm work on this? 6. Nope. Wait, but it's the exact same thing. I have an idea that may be a stupid idea. Already had oldest change. Cheers. But what if did this, but instead of just counting the hashtags, I counted these. Okay. I need to check my 3D print. Okay. It sounded like it was breaking. Okay, I mean, let's try it. 1174. Wow. Wow. That's crazy. That's crazy. That's the easiest part 2 I've ever had. I literally didn't even have to ask a question to ChatGPT on that one. That was my best day by far. Like by far. Wasn't my best rank, but that was definitely my best time, right? It took me from 12:55 to wait, what am I saying right now? Wait, what are these times? Anyways, I mean, checking my recording, I did this in under, I did it in like an hour and a half. That's pretty good. I'm really happy with this performance today. Yesterday was so much harder than today. I mean, today really was just finding differences between two nodes, and then this one was just repeating it. It was literally the hardest part of today was the wording of these fucking uh questions. That was the hard part of today was how it was defined. Because I mean, even that last part, like, um, did it say to count the? But you see, it says this means some of the new antidotes will occur at the same positions of each. So I was assuming it was just saying like, oh, these are a straight line, so it's gonna overlap like another antenna. But it's just saying that there could be the freak accident, or not. I guess I don't know if you call it an accident, but of like maybe perhaps uh it counted it like just by chance. I mean, is more what I'm trying to say is that every single like antenna, because it went like all the way, it overlapped with every antenna, and so it just you wanted to include everyone, but I'm assuming that is not the case. So cool. Okay. So now it's time to move on to the not so fun discrete math. I love this advent of code, by the way. It's so fun to do. It I don't know. I'm gonna miss it when it's gone. Um, so I'm going to hide my screen as I log into my campus. Oh, I still have to do that. This and then lecture notes. Okay. Okay. Now we go down to section 3. So last one was the regular expressions and languages. Introduction to regular expressions are a concise way to define languages. Example, A plus BA star B defines strings built from A, B, blah, blah, blah. So I won't lie, all this like regular language stuff, I know there's something like way up here as well for like cursive induction. I guess this wasn't that bad. But like just like the language theory or stuff, I hate. Oh my God, I hate. So that's something I actually want to look at is let's go to YouTube. Also, let's go there and let's go to what did I want? What did I want? Oh yeah, it's not Kalina, Cleany.
Okay, so let's speak about the closure property of NFAs. So what do I mean by that? You give me languages defined by an NFA, right? So you give me a language and you give me an NFA that accepts this language.
What is an NFA? What is an NFA? Discrete mathematics. Non-discrete finite automata. When there are multiple paths. So this is state
Give
stuff.
me two
Okay.
such NFAs for two different languages, and then I would like to do operations on those languages. For example, I would like to compute the union of those two languages, the intersection, or the complement. Right. So union is very easy to do. I'm going to show it shortly. Intersection and complement can easily be shown by converting an NFA into a DFA, something that is not trivial to do, but we will see how to do it next lecture. And since DFAs are closed under Clini star. So let's see how we do those things. So union, it's pretty easy. Let me erase the drawing and start from scratch. So you give me the two NFAs.
I'm missing something here. Death for search uniform, game answer, regular expressions. Regular expressions. Discrete mathematics. Regular expressions.
Now, what are regular expressions? Regular expressions are used for representing certain sets of strings in an algebraic fashion. So instead of simply representing them as we used to do till now, these regular expressions are used in order to represent our strings in an algebraic fashion. So before we learn more about regular expression, there are certain points or rules that you must remember, and let's see what they are. Okay, so these are the rules or points that we must remember about regular expressions. So let's see the first point. Any terminal symbol, that is symbols that belong to sigma, including the empty and the null symbol, are regular expressions. So till now we have seen many symbols like A, B, C and so on, which we use for representing the inputs and outputs. So all these symbols known as terminal symbols, including the empty and the null symbols, are all regular expressions. So that is what
Okay.
the first point says. Now let's see the
I need
second
the
point. The
concatenation
union
shit.
of two regular expressions is also we call R1 and R2, which is also a regular expression. Again have concat 2. I have already mentioned and discussed about disclosure in one of our previous lectures, but let me just repeat. A. This is especially are they are simply the
Regular expressions with regex. I want to look at this.
Patterns with to search. Its two most common use cases include the validation of user-generated input. It's notoriously difficult to learn because its syntax ends up looking like a meaningless pile of gibberish. For example, in JavaScript, you can use match to find or search first in your.
That's what I need to learn over winter break.
Welcome to Frank Diana Explains and to the Formal Languages part of the Discrete Mathematics course at Cambridge. Exposed maybe because you've used regular expressions in a scripting language such as Python or Perl. In this course, I'm not going to teach you how to write and debug complicated regular expressions. We shall instead concentrate on the fundamentals, on the expressive power of regular expressions, on their limits, and on how they relate to regular languages. And we shall start with a very mathematically flavored distinction between concrete and abstract trees.
Okay.
Abstract syntax trees, and then the next slide instead says concrete syntax. So are we talking abstract or concrete? Is of a slightly made show the abstract version of what we had previously, where these are things that are not linearized into a sequence of symbols. They're represented here as a tree, and the nodes in this tree are vertices which combine subtrees, and so the let is a thing that combines this function over here, which is started by this fun. In fact, I should really be taking the previous slide again. It's a bit to do, but I'm relating sub-expressions of my previously linearized concrete syntax into chunks that make sense according to
Okay, I understand this.
making this introduction because we want to give syntax for regular expressions. Regular expressions is something that this is supposed to teach you from zero, but every time I get to this point, I see people have already seen regular expressions to death. Is there anybody in the audience who has never worked with regular expressions? Then hands up if you've never seen regular expressions. There's 2, 3, 4, 5, 6. Coming out of the woodwork now. Okay, right. There are a few people who've never seen regular expressions. Okay, for their benefit, regular expressions are a way of expressing patterns in the spirit of when you are in the command line shell and you say, instead of naming files, you say list all the files that finish with .txt by putting star.txt. That's a way of expressing a pattern. That pattern is not a regular expression. The regular expressions are a mechanism for expressing more complicated patterns, and there also exists an asterisk in there. But
Dude, I took a discrete math earlier, and this one's a computer science discrete math. This one's so much more interesting, and I would have tried to put more time into it this semester because, I mean, this is cool how you do like. Remember the advent of code we were doing a couple days ago, and I showed the Primogen who solved it with like a macro. That was with a regular expression regex. Oh my god, regex wait. Wow. Okay. Regex is regular expressions. Jesus.
Repeat the previous regular expression 0 or more times. And in fact, the regular expressions, as we are going to define them in this course, which are a kind of strict, no-frills version of the regular expressions that you might find in your Unix tools, are based on the alphabet of the strings plus these meta symbols that don't occur in the actual strings of your language. And these symbols are this other epsilon, and notice the difference between this shape of epsilon and the other one that we used previously, which looked like this. It's not the same as this epsilon. So this epsilon over here meant the empty string, and this one means a regular expression matching the empty string. This symbol that looks like the empty set means a regular expression that never matches anything. This vertical bar means the alternation of two things. So you can take the thing on the left or on the right. This asterisk means repeat 0 more times. And these brackets are there to express of strings and the meta symbol over the alphabet given by the alphabet of your basic strings and the meta symbols. Regular expressions in concrete syntax are themselves just strings of these symbols. And I'm going to inductively define the shape of a syntactically correct regular expression by saying that any of the symbols in sigma is a valid regular expression. This special epsilon that says a regular expression matching only the empty string is a regular expression. This other meta symbol, which means a regular expression matching nothing else, is also a valid regular expression. And then if the things on top are regular expressions, then the things at the bottom are also regular expression. Wrapping one in brackets, alternating between two of them, concatenating two of them, and repeat.
Hold on, I need to fix 3D print. Ah, I fixed it. It's going pretty well now with the 3D print, but bro, I won't lie. I don't care, bro.
Derivation.
It's like, what am I learning from this? I don't know. Ah,
In the last lecture,
that's
I
what I
have
want.
taught you the rules that we need to remember for
Actually, you
converting.
know what I should do? I should just go through all these and like so these are
In the
Welcome.
I want this guy again. You can think of a finite state machine as a program that is only allowed to use a finite amount of extra memory. For us, they're primarily a theoretical construct, but they show up quite often in practice. Pattern matching, programming, hardware design, linguistics. All words that are built using the letters A and B, at least 2 characters long. Oh, so it's built with this plus this, and then it's as long as that time. I just put my fucking foot in my PC and it hit the CPU fan. That scared the shit out of me. I have my case off because there's shit cooling in my PC and it's better with the case off. Anyways, and is all A's except that its last character must be B, and its first character can be B, contains at most 2 B's. You're telling me this says all this. Okay. I wish I had started doing this like last week. It'd be so nice to take like 3 lectures at a time and actually read through them. But like, I literally need to get through all these lectures today. R and S are 2 regular expressions denoting the languages of. Okay. Clean star operation. If A is any language, the clean star of A is a set of all strings that can be written as the concatenation of 0 or more strings from A. Okay. If A is nothing, then A star is that because we only have the concatenation of 0 strings. If A equals A, then A star is A, blah, 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 infinite A's. If A is AB, then it can be AB, AB in that order, always in that order, set of all ABs. Clean star operation, if A equals an empty set, then A star is just the empty set. So the star notation we must be using is the same. So the star notation we've been using for, okay, beautiful. Because I know we've seen this a lot, but this is the actual formal. Okay. In general, A star is the union of all languages, A0, A1, A3, where A star equals empty, A1 equals A, A2 equals A, A3, and so forth. Examples: A plus B squared is AA, AB, BA, BB. AB is AB, 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 AB. Okay. So this is the concatenation of either of these twice over. This is just this, but like, so it seems when you have the star, right, it's infinite because it's every single variation that you can keep adding on to, right? So like this is the same as this, but with a C. So it's like A B A B A B C A B A B C A B A B A B C, and then it'll just keep going on with A B's and then a C at the end. This is the exact same thing as this, just with a C in the end. Okay, I see. I see. I see. I see. Finite language is the regular expression ABA denotes the concatenation of A, B, and A by the definition of concatenation of languages. Thus, any language consisting of a single non-empty string has a regular expression, which is up to a typecast itself. The language empty, as we just saw, can be written as that. You can do any finite language by the regular expression. Okay, for example, finite language was noted by the regular expression. Nothing's Kaylee's star plus that plus that plus that. Note that the plus is not Java concatenation operator. Okay. Meaning you would just put this all together. It means it's separated by that. A regular expression must never use the star. A regular expression that never uses star operation must denote a finite set. Yeah. If we use the star operation on any language that contains a non-empty string, the result is an infinite language. Which of these strings is denoted by the regular expression? It would be AA. So it would have to be AA, BA, B, BA, BBA. So this first one's not correct. How is this correct? Wait. Are these sets of strings denoted? I thought that AA plus. Oh, it's just either of these. Either. So the plus is like an or. So it could be just AA or it could be BA. So it could be AA and then BB. Wait, AA with a B, BA, but then with an A. I see. AA ends with a B, BB. Oh, BB ends with an A. Then it could be BA ends with a B. So this is like this has to end with that. This is kind of the plus is like an or. I have to fix the print again. Right. It's like every time I randomly hear plastic scraping, meaning like it went to that part that I said is not printing anymore because it missed the first couple levels. So it's just like making a blob and it scrapes across. And then, I mean, thankfully, most of the time when it starts drawing, it'll just drop it off at the beginning of that. And so I have to like pluck it off. But I really hope it doesn't fuck this print up. This is a 12-hour print. So hopefully it doesn't get like 6 hours into it and I've already used a bunch of printing stuff. I don't know. We'll see. Um, Okay, I see. Let X be the language denoted by the expression AB plus BAB star. Which of these is true? Any string in X. You can have back-to-back B's. Can you have back-to-back A's? You can never have back-to-back A's. So any string in X contains neither consecutive A's. No. There could be consecutive B's. I think B is correct. Every B in any string X has immediately an A before it. No. It has to be B. Yeah. Largely describe languages. We can first say that the first letter is not B, and there are never two B's in a row in the predicate calculus. One way to do it is to have variables that range over positions in the string. Our atomic predicates are the position X contains A. Okay, position B contains A. X and Y are the same position, and Y. X is to the left of Y. Okay. Oh, I didn't see this. I was like, less than Y equals X is. Okay. So we can say that the first we can say that the first letter is not B. Means there exists an so this was what? Position X contains B. So there does not exist an X that contains B, and there contains there for all Y, X is to the left or equal to Y. So which means X is first. Whoa. Whoa. I mean, this is the not. Is this not? This is, there exists an X. So there does not exist an X where X is in, where X contains B. And for all of Y, X is either to the left of Y or it's equal to Y. Or they're at the same position. Okay, so because it's saying that there doesn't exist a position X that contains the letter B. No, okay, this is position X contains B, so there doesn't exist a position X that contains B. And for every single Y, X is going to be to the left of Y. Very weird that there are never two B's in a row. Oh my god. Doesn't exist the F, there's just a Y where X is position of B and one way to say both things at once is there exists an X where X is, what is this? X is, position X contains a B. Position X contains a B. There exists X. I'm going to ask ChatGPT to translate these to English. Translate these to English. There is no position in X such that X is the position of a B and X is the first position in the string. Since S is less than or equal to all positions Y in the string. There do not exist two positions X and Y such that both positions contain a B. X comes before Oof. It's heavy, bro. Let L be the language described by the logical formula. Consider the 5 strings. How many of them are in language L? So we're saying for all X, the position X contains B. There exists Y where Y is on the left of X. I don't understand these, bro. Yeah, I need a ChatGPT to explain this one to me. For this question, first solve it, then show me what I should be looking for in these expressions to see if they follow. Also, how I can easily translate them to English. For every position, right, for all X that contains a B. So for every position that has a B, there exists a position Y such that Y is at or after X. And the character at position Y is an A. So it's just saying for every single position X, there exists another position Y such that Y is at or after X. And that's a B. So, I mean, knowing that, wouldn't that mean that this one's okay? So what, 2? 3. Oh, including the empty? Wait, what did I say? I said this one? This one? It says that any letter... How? If there's an A here? Oh, I guess it's just not saying that this can't be before it, right? It's just saying that if there is a B, there has to be an A after it. So there could be A, infinite B's, and then one more A, and it's fine. Okay. Weird. This is implies. I forgot that. So it's basically saying for every position X, there exists a B that implies this regular expression that there's an A that follows. Okay. Okay. Let's go next. $29. Proving regular language identities. Um, check the print again. I'm back. I quite literally, I got something to eat and just chilled for a little bit. Actually, I need to pause one more time. I'm sorry. I need to check DMs. Oh, I'm back. But I went to go check my GitHub for web programming because I'm supposed to have a meeting in 40 minutes, but it looks like no one's actually saying anything. I'm gonna check it. I should actually send a DM. I should probably do that. Okay. I had to send a message to see if I am doing a meeting in 30 minutes or not. For web programming. Tomorrow I have to work on stuff that I'll probably do off this recording. Because it's like documentation, just boring stuff that I'll probably do in the evening. But yeah. I need to start sorting through these lectures right now. So yeah, so what I was doing was what was I doing? Oh. Now on in this chat, I will be using it as a way to summarize slides into notes that follow the exact same outline as the example I will post. Then I will paste the entire lecture slides so you can summarize them for me the same way as the example. Oh, that's not what I wanted. I want this and this. While it does that, we'll quickly go through this. Okay, I already looked at all this from last time. No expression identity. In this lecture, we'll go through formal definition of regular language, blah, blah, blah. For example, if we view the unit operator as addition, then the rule is you gonna check the print. Kind of funny every time I go up like every 10 minutes, there's just this little like string hanging off, like because it always does the same pattern of like tries to like fill in the next layer here, and then it'll go over, and then the second it goes there and it starts like spitting out, it'll just like stick it on and then like continue to print. So there's this little tail that I have to take off. All right. So regular expression identities. We can use the inductive definition of regular expressions to prove the statements about the whole family of regular languages. The ordinary operators plus form an algebra structure called smearing. The book proves the smearing axioms for the natural. Turns out that the actual regular languages are subsmearing because they are closed under. That just means that if R and S are regular, then R plus S in R times S is also regular. The natural numbers form an algebraic structure called a smearing, obeying these axioms. There are two binary operators, plus times. Both operations are cumulative. Both operators are associative, and there is an additive identity called 0 and a multiple entity called 1. Multiplication distributes over addition so that for all U and for all of V and for all of W, U times V plus W equals U times V plus U times W. Wow, okay, yeah. That is just regular mathematics. Details of those smearing axioms copied from the books. Commutativity means for all this and this. This plus this equals that plus this, just vice versa. For all of this and this, that times that is the same thing. Associativity means that equals U plus V times. Wait. Oh, no. I'm stupid. That plus that. Okay, yeah. And identity rules are 0 plus U equals 0 plus U, and 1 times U equals U, U times U equals 0. Yup, the smearing axioms again. Both operations here must be associative and both have an identity for languages of null. It's the identity for union plus the identity concatenation. Okay. Note that plus is commutative. It is not as in general. X, Y, and Y, X are different languages, yeah. On the other hand, there are other important identities such that X plus X equals X is independent. And they're true for languages, but not true for natural numbers. Consider the rule X plus Y equals, we're squaring denotes multiplying an element by itself. Which of these? We're squaring denotes multiplying an element by itself. And the rule is never true for any. Okay, the rule is always true if X doesn't equal Y. It's B or C, I think. Yeah. The rule is true when X equal Y if, because this is saying what? If X equals Y, but B says that is equal to also works for X. I've already proven everything we need to know about identities. Adjust these modes for every language since the set identity tree. So we know that for sets of strings st within that language, s plus t is t plus s, s plus t u is t, s plus t plus you go to s, s yeah. We looked at concatenation of languages, statements like s times tu, s times tq. Yep, we just went over that. Maybe prove by the equation sequence method to prove x equals I. For example, we let w be an arbitrary string, and we proved that. W exists in X, and W also exists in Y. For example, to prove this, we note that if W exists in S2U, and there exists a U and exists a Z in which W is equal to UZ and U is equal to ST and Z is equal to U. There exists an X and Y and Z in which W equals X, Y, Z, and X equals S, and Y equals T, and Z equals U. And there exists an X and a V in which W equals X, V, okay, and X equals S and V equals TU. So W exists in STU. I don't get that actually. To prove identities about the clean star operation, we use its alternative induction definition, which we still need to prove. If A is any language you define by 3 rules, nothing exists in there. If Q is in there, then V exists. Oh, if U is in all of it, and V is in the original, then U times V exists within that. Okay, yeah. And a string is only in if it can be proved to be also so. Okay, sure. There's a definition of star. Blech. What, strong, structural, and strong? The first definition, I'm gonna check print again, sorry. I'm back. Are these fucking earbuds always get so tangled up? But I love these earbuds. Anyways. The induction definition of star. Okay. New def A star is defined by 3 rules that we just read. Okay, the first definition we gave earlier. W is in A if and only as W is a concatenation of 0 or more strings, each of which is in A, is equivalent to the second one above. Why? By induction on natural n, we can prove that any concatenation of n strings from A is A star according to the second definition. Any concatenation of n strings from A is A star, yes. So any string satisfying the first condition satisfies the second. Okay. In the other direction, we can prove that by induction on all strings W within A star, according to the second definition, that there exists an n such that W is the concatenation of n strings from A. So any string satisfying the second also satisfy the first. Okay, structural induction. This is an example of a general phenomenon we have seen before. Structural inductions on the definition of a class could be rephrased as an induction on naturals. Another example for some PW, rather than proving PW for all strings W, we could instead let Qn mean PW for all W of length n, and then prove Q of n for all naturals n, P of W for all W of length n. Okay, the proof of Qn implies that Qn plus 1, okay, that's an induction, would essentially be the same proof as PW implies PWA. So just concatenation of like PW. So like beforehand we were saying like, oh, here's Qn, so Qn and its next thing this is saying PW and then PW plus like another string. So if we let the language AB and then let PW for W within that be W does not end in AA or BB. PW means that does not end in AA or BB. But is that false? I guess. I would assume if the language is AB, then yeah. But here, can't this be anything? Couldn't this be AAAAB? Anyways. Let X denote the language AB plus BA star and proving for all W there exists a W in X which implies this. What's the base case of this induction? So we're saying for every single W, right? So for every single like string, a W within X, and X is the language of AB plus BA star, meaning it can be AB. Oh, okay, I see. This is the language of AB, and then we have X. I guess I just don't understand this. What is this saying? Because I get S. This is the language, and so this language star is going to be AB. BA is one, or AB, or BA, or ABBA, but it'll never have two They'll never have a string that trails with the same two letters. I'd say the base case would be B. Wrong type, yeah. Misses case of yeah. And then PV equals yeah, that's the inductive step. Yeah. God, I hate induction because it's like it's so easy to like define the base case, but then when I actually get to the inductive step of like so like you do this as like the inductive step, and then to actually proof it, you have to use the inductive step and you have to like rearrange everything, and I just get lost in that shit. Identities, the statement U exists in this and V exists in this means U and V exist in that. Yeah, A star is closed under concatenation. Definition, okay. Our statement is U exists in A star, which implies U and V exists in A star, where we have to let U be arbitrary. The base case is V equals that. It's clear that if U exists in A star and V is nothing, then UV equals U exists in that. Okay, yeah, sure. For the induction, using the second definition of A star, assume that. Uh-huh. What is going on here? It generally is much easier to prove subset relationships than set equalities from the definition. Quality identities between stars show that S star star equals S star mostly be proved by direct definition. That S star star is using S star and S star equals in that. Okay. Let's prove star that if S is in T star, then S star is in T star. Assume that S is in that. Let PW be W in T and prove that PW for all W in S. For base case, we have this. We know that nothing is in T star for induction by the second definition. Beginning star W equals XY, where X is in there and Y is in S. By the inductive hypothesis, X will be in that. And Y will be in that because S is in that, and we said Y is in that, and then by closure T under concatenation, WY is in T star. Okay. Let S and T. Actually, let's read this. Okay, yeah. So let S and T be any regular expressions. Which of these statements must be true? S star T plus. That looks so fucking weird. But no. This is S star and S star, right? S star times T plus T. Actually, that could be right. I like how that looks, but I doubt it's right. Like just doing the opposite and then starring all of that. Oh, it's 100% C. Oh. Mrs. T. How does it miss T? Okay. I want to see what this produced and see if what I just took away from all of that lies in here. And in that case, I'm just going to keep spitting into ChatGPT and not even looking at the slides, to be honest. So, introduction to this, p-focus, union, concatenation, smearing axioms, set of operations, commutativity, identification, distribution. Union identities, yep. Distribution law to prove. Oh, I love that. I actually really like this. So I think what I'm going to do is I'm going to separate these and I'm going to put Chat GPT in here. Because I can easily just go through this a lot faster. Because I mean, the whole idea is this isn't like right now. I'm just supposed to get familiar with all these topics, and then Monday, Tuesday, Wednesday, Thursday is when we're going to do a deep dive into actually trying to flesh out the big. Like we've gone through all the finals and we've kind of seen what is on all those finals, and I'm just going to see like um what is going to be needed to path, like what I need to study exactly. Wow, this page is like lagging because there's so much like stuff on it. Did I not get? Oh, what the fuck? Um, I need to check on 3D print while that's doing its thing. Back. Accept. You know what I need to do? I need to separate all these into like different things. I should do that right now, honestly. It's like how I have, above is documentation for discrete math. I should do like section 1, lectures 1 through, I forget what it is, like 17 or something. Section, and then I'll have like this. Or not. Section 2, lectures like 18 through 28 or something like that. And then section 3, lectures, no, 20, this is 28 through 39. And then this is like through 27. And then final exam study. So what I want to do is make 1, 2, 3, 4. I want this to be section 1, CIS 250. Section 2, CIS 250. Section 3, CIS 250, and final exam review 250. Okay, and then I want to go back to Notion database, discrete math. One through 15 is what it was. Actually, you know what I should do? I want that. Then that. Paste and sync. Three. probably change all of these to like lecture 1. Lecture 2. Oh, not that. Lecture 4. Five. Lecture 6. Lecture 7. Lecture 8. Oh, lecture 9. Lecture 10. Lecture 11. Lecture 12. Lecture 13. Lecture 14. It should be finally lecture 15. Right? Nice. Okay. So there's that. Now I can go back to discrete math. Beautiful. Section 2. Oh. Section 2. Should take me down all the way to here. The only thing was like, two more down. This, what is this? This is an H3. Those are H2s. Okay. Now I'm on section 3. So this was through 15. This was 16. So what I can do now is... I need more room so I can open both of these up at the same time. Section 1. Plop. Go back. Fucking hell. I'm like trying to click after it. Right, and then section 2 will go right here. A divider. Actually, just turn these into headings. Um, fuck. It's easier to go up. Section 3 is right there. Okay. And last but not least, this. Not actually, this actually is not last. Need to check on that print. Back. Where were we? I don't need this open yet. Stop. Why did I do that? Alright. The only thing is, why isn't this... Oh, I'm stupid. These are so cool, bro. What block is this even in? What block is this in? It's a quote block. Cool. By the way, I don't know if it's... I've been trying, like, paying for this, like, Notion business thing. It's just it's a little pricey. It's like 20 or 30 bucks a month, which I think I'm gonna cancel. The only reason I had it was because you couldn't, like, export pages for, like, my homework, so I was just doing it for the semester. But the whole, like, AI thing in here to, like, format my stuff to, like, so, like, now when I, like, if you saw earlier when I did that, like, clean up extra characters from, like, the paste from ChatGPT, if I do Control Shift E, it just makes this into, you know, like an equation. So it's pretty cool because otherwise I'd have to go through and format every single one of these, but instead I can just hit the key. It's still like inefficient. I'd rather be spending my time doing something else, um but yeah, it's pretty cool. Here, let's just do this before I convert all these. Just so like when I open this up, I have this in here. I think I can just delete it afterwards, but I wanted, well, to first just delete all that, and then finally take this. Not what I wanted. I want to do this in blocks. Final exam review, paste. Beautiful. So now I can go back here. I can go to discrete mathematics. I can open up section 3 and paste it in there. Divide. Make this that. And put U right there. Beautiful. And then the idea is I can just delete that. And so then I can just come in here to discrete mathematics. And then right now I'm working on section 3. Okay, sick. Now comes this really boring part that I'm going to have to do every time of formatting these notes. But at least that's all I have to do, and the AI does the rest. Because I haven't been able to find a prompt that actually does this for me with the in-app. Like, I just heard like the biggest crack come from the 3 printer. That was so scary. All it was doing is I have to keep going every time it like puts like some of the stuff on top, and it just ran it over. Thankfully it didn't really like mess anything up. It's just I just have to every 10 minutes keep going back and forth. But I'm way too far in the print now to stop. So I was gonna say, I was going to see if I could do like highlight all of this, then ask AI and go like, for every expression that falls between this sign, convert it to a math equation. So for me, that is Control Shift E, but I want each of those converted. Let's see if it does it. You're not gonna let me scroll up and look? Oh. I think it's actually doing it. Wow. That's beautiful. So what I can do is I can copy it here, tell it to clean out all of the extra characters that it gets pasted in because it's just different pasting. And then format it for math. So what it does is it identifies all the math things and it like puts it in here, and then I can go through again and say turn all these into that. That's beautiful. Okay, thank God I actually tested that. Okay, yeah, and that was the lecture we just went through. So now I can move on to the next lecture, which is 30, which is proving properties of regular expressions. Okay. Do the same thing now, but for these slides. Except it's doing 1, 1, 1. I guess while that's loading, I can just change it. Ah, properties of regular expressions. Selects or explores key properties of regular languages, including their inductive structure and one complement operation. The methods for testing properties of regular expressions below is a structured breakdown of the lecture. So is this what happened on this one as well? Sort of. Lecture focuses on induction. Okay. Since regular languages are defined inductively, we can prove properties about them using structural induction. Predicate definition. Let PR be the predicate with one free variable R regular expression. To prove PR for all regular expressions, we prove it for the empty set and for all A in the language. Are true, then PR plus S, the unit of SR holds, the concatenation holds, and okay. One's complement operation. The one's complement of a binary string denoted OCW is obtained by flipping all zeros to ones and ones to zeros. OC, okay, inductive base case. 1, recursive step. One's complement of language X. OC X equals OCW W. Apply complement to every string in X. If X equals 0 star 1, excuse me. I'll check the print again real quick. I'm back. Probably this is a recursive algorithm. Actually, also tomorrow I have still a lecture for this class left, so it would be very nice to finish all these lectures today, and then actually tomorrow I don't have to be to the school until 1, to be honest. So leaving at noon. I'll allow myself not to finish this today, but I need to set up all the content that I'm going to, cause yeah. So I would say what 3 or 4 left tomorrow. So if I can get through 35, no, 36, 38, 39. Yeah. So if I can get through the next 5, wait, 30, 31, 32, 33, 34, 35, 36. I'm not getting through all 10 today, bro. No shot. Not even like no shot. It's like I wouldn't even grasp all of it right now. So, I mean, even this, I'm having a hard time like grasping what the fuck's going on. Oh, definitely one compliment. No, I wanted this. That's what I was looking for. So says that L of R equals. This is true because yeah, P of 0 states that L of R equals. This is true because L1. Wait, what was this? Formally, this is a recursive algorithm. F of nothing equals this. F of 0 is 1. F of 1 equals this. The inductive cases are F of R plus S equals F of R plus F of S. F of R S. Yeah, okay, that's just. So because we define that, that's true. Proving our function is correct, assume that P are also true. We must show that. Further state that our rule of F is equal. I'm trying to prove that OC stars is a subset. On me. Dead one. Come back. On me. Dead.
Solo.
On him. Okay. Alright, I'm pausing again. Alright. I hope you enjoyed that little Fortnite session. Of like 20 seconds. But I played for like 3 hours. So, you know, just a little break. Tiny one. Yeah, let's go back to this. Where were we? Because it has been some time. I was reading through this. So I kind of understood that. Here I was lecture 30, right? At like, I don't know what page. Oh yeah, it was this. Regex class. Just the Boolean arithmetic expression can be implemented. Oop. Close that. Box mod. Regular. We will need to. We must determine their structure and components parts. A Java regex class. This is write code for one's complement algorithm. The next slide is a recursive method that creates a regex object with the same structure and methods, arguments, but with ones and zeros switched. We've essentially proved this method correct by a usual method of recursive code. It'd be cool if I could do proofs on my exam using like actual code. Like if I could like write it out in code, that'd be cool. Reading one's complement. So we have a public static regex. If so, we pass through a regex expression called s. If it is empty, we return just a new regex. If s is 0, we return a new regex 1. If is 1, we return 0. Oh, if is 0, we return run. If not, we return regex 0. Regex OC1 equals regex OC1 equals f s dot. Oh, this is the recursion, right? Regex OC1, this is equal to the function f passing through s dot first arg, right? If s dot just star return regex OC2 equals this. If s is plus, return this, else. Okay. Reversal of languages. Similar function from languages to languages is reversal. Is not familiar reversal operations on strings. Running from a language XR, WR. Okay. The regular languages are closed and are universal. We can easily see that and we have that. Okay. Computing reversal. Right, so same stuff. For the case where S is a union, or contains a line plus. A, right? Yep. Reversion the different expression, but equivalent to the one is returned before. For example, S plus R would be R plus S. That's what I assumed. I didn't even read these because it just makes sense. Yeah. Okay. Testing for empty language. The regular expression denotes the empty language, but so do other regular expressions like this. Okay. We solve the problem recursively for the base case. Telling whether it is much harder. because critical. Okay. Given a regular expression R over AB, I would like to compute whether which of these potential steps in a deductive definition is valid property. So we're saying isn't not A again? Why would we be using S? It's probably not A, but why would it be? Okay, that's it. Okay, cool. We have to prove option A refers to elements in. Says nothing about that. This is the one I wanted to look at. Was wait, I never did the third one. Redo this, but include clicker number 3 as well, please. Every let me check out how much longer is on the print. It's so funny. I've been like printing like these really shit prints all week. And now that I'm doing a 12-hour print on the stuff that I've been doing in like an hour and a half, it's just so weird to see like now there's just so much detail into like my exact print. So like hopefully I did the dimensions right and this is gonna work beautifully. And if not, guess I'm getting a 0 on the project. So I'm just kidding. I'll figure out something. Give me all that. Enter. Paste. Undo. Why didn't I copy all of it? Lecture 30 all the way down to here. Enter, paste. Ask AI. Remove the extra characters and format for latex. On the dead ones. Red rum. Red rum. Red rum. I don't think I said the print has like 3 hours and 40 minutes left on it. That's not good. I need to hurry up on this. It's going too slow. I already know like what's going to be on the exam, and like this stuff. See, but it's going to be important, and I know it is. Like this is like a foundational thing. My Notion is really lagging. Like the image on this. Is that what they're saying? Red rum. Maybe we're gonna have to do this chunk by chunk. Probably like right there in my build right now. It's so great that this little Doyle down there finished right here. So I didn't have to worry about it anymore. This is crazy. I thought I had this. Well, that fucking sucks. That really sucks. I wonder if I can do. Okay, I'm back. Sorry. Father came in. Oh, father, oh, father. Um. Nope. On that. It'll be sick if ChatGPT actually formatted this correctly. Good enough. Um. I wonder if this works, bro. Fuck, bro. It like doesn't. Like for this, you just remove the lines and it's good. I wonder about this. Given by, like when I do this. Oh shit. Great. Just remove the front slash and back slash from both sides. So confused. Like here, it has like this, right? Uh, I think what I'm gonna do is stop recording after this lecture slide, and then because I need to go do some stuff. I'm gonna finish up this print. I'm going to try. I'll wrap it up later, but I'm just saying. Because this is a big one, bro. This deterministic finite automata. We now turn to finite state machines, a model of computation that captures the idea of reading a file of text with a fixed limit on the memory we can use to remember what we have seen. In particular, memory used must be consistent, independent of the length of the file. We ensure this by requiring our machine to have a finite state set, so that at any time during computation, all that it knows is in which state it is. The initial state is fixed. When the machine sees a new letter, it changes to a new state based on a fixed transition function. When it finishes the string, it gives a yes or no answer based on whether it is the final state. Yes mean it is the final state? No, that is not. Because the new state depends only on the old state in the letter seen, the computation is deterministic and the machine is called the deterministic. Wait, because the new state depends only on the letter seen, the computation is deterministic. The machine is called deterministic finite automata. Where we are going. A DFA is the size of the language. It reads a string over its alphabet and answers yes or no, depending upon whether it ended in a final state. See, like this stuff's cool. These last two lectures, boring. Okay. The language of DFA, which is the language that decides the string, set of strings which it says yes. We call the language X recognizable if there's a DFA whose language is in X. We'll prove later that some languages are not recognizable. Okay. One thing I want to do is go back again. Wait, can I not go back again? Oh. No, I can't. Okay. Not what I wanted. I want this. Transition function. Oh, interesting. God, it'd be so nice to have an AI to do this for me right now, but I ran out of AI. I pay for like business class, but oh well. I just already know, just from the way this was looking, it looked really nice, so I want to make sure that this is in my notes. Uh, Wait, what was this? To the what? To the nothing power. So much more to do. Bro, I can't wait until finals is over. And my days can just be all cheery and happy. I can enjoy time with my family and friends and not have to do discrete mathematics. Even though discrete mathematics are kind of cool, but I digress. Is that? Holy. Wait. I just realized. Wait. I just realized. Don't talk to me. Why didn't I just do that in the first place? Why didn't I just use the built-in browser regex find and replace? Am I right? Oh, this is that though. I'm fine with that. And the last thing I wanted to do was pick a question 9, blah, 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 blah. I wanted this to be H3. No, I wanted this to be H2, didn't I? Let's make these H2. Okay. Missed one. All right, here. Okay. Now I can go to lecture slides. Oh, this is actually 31. I thought this was only 30. That's really nice. The Mahale-Nerode theorem will give us a way to take an arbitrary language and determine whether it's decidable. We'll define a particular equivalence relation on strings based on the language. The relation has a finite set of equivalent classes that exist in DFA that recognize the language, and there is a minimal DFA with as many states as there are classes. We'll see how compute the minimal DFA. As we previously mentioned, there's a DFA. I'm sorry, what's a DFA again? Deterministic finite automata. That is, if and only if the language is denoted by some regulars. We'll prove that this result, called Kleen's theorem later, over several lectures. Our proofs will show us how to convert a DFA to a regular expression and vice versa. So this is a big part of the final, by the way. I think this is like 40 points of the final. It's going to be these last lectures. So I really need to focus on these, and I'm going to have to go back and do some more regular expression stuff, induction stuff. I'll talk about this actually in like 5 minutes when I'm done with this. What are the DFAs? DFA is defined, actually, no, it's defined by its state, set, initial state, final state, input alphabet, and translation function. We represent DFA by diagram labeled directed multigraphs with a node for each state, a special mark for the initial state, a double circle on each final state, and an arrow labeled A from nodes S1 to S2. Whether, okay, a different example. So state S is 1, 2, 3, 4. Just lists out the states. The initial state is 1 because we come in here. Final state is 3 because there's a circle there. It's over the alphabet A, B because between all these there's A and B. And the transition function is, okay. The transition function is a function from state to letter. Pairs to a state. That is, you end up in a state when starting in a state in reading letter. For any string, we can follow the arrows for its letter. The strings A, AB, and BB are in this language. The notion is that the machine starts in state I. It has a tape that it can read one character at a time moving forward. After reading each character, it uses the transition function to figure out what its next state will be. If it's in the state, when it finishes reading the tape, the string has been recognized and accepted. A DFA example. For any string, we can follow the arrows for its letters in order. The strings A, BA, BB, BAA are in this language. String A, okay, starting is here, right? The state, DFA will be reading, okay. So we go 1 to 4. So B. And we go to 2, which is also a B. Then we repeat 2, which is a B. Then we go back to 4, which is an A. Then we go to 3, which is an A, which is the final state. Since reading string A, so BBBAA puts the DFA into the final state. 3 is in F. A is in this, okay. A is in this language because we can go from initial state to final state by forming the string. Okay. Similarly, both A equals A and B will end at 3 because we can just go here, that's A, and then BA would be down, up. But ends at 4. So if we want to go B, 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 A, yeah, we'd be at 4. Which of these strings is not in the language of this DFA? Okay. So we can do B. We can only go to B to start out, right? So it has to be. Am I crazy? It has to be a B first. So wouldn't all 3 of these not be in there? Like this one, you can go an A or a B. No, you can get an A. What am I saying? You can't get an A. So you can do B or A. Once you get here, you can do B, and you can do B again, and you can do B again, and you can do A, 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 and you can do B, B again, and then you can do A, B, A, and end up there. Okay, so that's good. So it's not D. First one, A, 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 A. I think that one's good. A, B, A, B, A, B, A, 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 B, A. So it has to be C. Okay. I like how I went through every single fucking one except for the one that it was. Behavior of a DFA. The behavior function of a particular DFA is a function called from such that the state of the DFA after it starts in state P and reads the string W. Okay. Formally, we say that whatever you want to call this. What do they call it? Because I know it's a highlighted key term here, right? Delta. Okay. So delta star P lambda is equal to P in that PW equals to that. Okay, the language of a DFA is defined to be the set of strings W such that is the final state for a DFA M. We call this language L of M. For more examples on DFA, one of the most popular DFAs does have the language of binary strings with an odd number of ones. It has two states, E and O, representing whether the machine has seen an even or an odd number of ones so far. The initial state is E, and the final state of the set is 0. The transition function is okay. We can build a 4-state DFA for language EE of strings with an even number of A's and even number of B's. States are EE, EO, OE, OO, and as an example, delta star EEW equals EO if only and if only W contains an even number of A's and an odd number of B's. EE on a state will equal EO if there's contains an even number of A's. Oh, so you could start on the final state as well, okay. Input to be like a file with a method to give the next letter and one to tell start letters. Boolean is final equals new Boolean of states. Natural does a 2D array chat. New natural states letters. Start while input isn't done. Current equals get next. Return is file. No, okay. The strings with a behavior. How do we prove that a particular DFA recognizes a particular language? For the even odd DFA, we would need to show that the next state equals E if W contains an even number of ones, and oh, sure. I'm actually just going to go to this again and just read from here. Example. Each state represents a certain memory of what has been read so far. Actually, just skip through here. The no ABA language. The no is a set of strings that do not contain any ABA. For example, ABB, AA, blah, blah, blah. Language. Set of strings that do not contain. You can build a DFM for no ABA with states 1, 2, 3, 4. Right there. Final. I need to learn about this transition function more. We call 4 a death state. We can see that that an ABA will take us from any state to an ABA. Oh yeah, I see. Suppose transition 1 equals 2. Which statement could be not true of W? C. A. Fuck. Characterizing the states. Let L1 be the set of strings that do not contain ABA. And don't end in A or AB. Let L2 be the set of strings. Okay. Instead of 4 strings, the data has there's a string W that exactly one string. Which one of these pairs of strings is not? B. Fuck. If M is a DFA with the transition function, L is any language, U and V where L. This distinguishability theorem. If there exists a set of K pairwise L distinguishable strings, then no DFA that decides L can have fewer than K state. If there are more strings, then there are states by pigeonhole principle. There must be two both strings U and V such that, in this case. Okay. I need to revisit this tomorrow. So let's write Advent of Code went Advent of Code today went great. Went great. Used little to no chat GPT and didn't use it at all for the main logic. Did I learn anything from today's? No, really. It was it was quite straightforward today. I didn't get to this, and I am okay with that. I want to focus on Advent of Code and discrete math this week. And lastly, review these sections. I got through section 31. Need to review it again for distinguishable finite automata. Then go through the rest tomorrow morning before lecture. Then I need to get material for studying for practice together to do for the next 4 days. Okay. So yeah. Successful day. I like, there's a lot of interruptions and breaks that I don't want in the future, but still, I mean, went through a bunch of regular expression stuff and just like concatenations. I still am gonna have to review this a little bit. But yeah, this all went pretty well. And then obviously now we're on to state machines, which I know is a big part of all of this. So yeah, I'll be back. I'll be back tomorrow in the morning, where we are going to go through hopefully the rest of the lectures, which was going to be a lot, right? 32, 33, 34, 35, 36, 37, 38, 39. I have to go through 8 lectures tomorrow, and try to get a grasp of everything that's going on. I don't need to understand how to solve all of it, right? I just want to understand what the parts are of everything. And then I think tomorrow it's just gonna be spent on just solely on this on this like lecture 3, on this third section of just, I think I'm just gonna focus on the state machines. That's what it seems like on the finals. I think tonight I'll go through and pick out all the stuff I want to get done in these next 4 days before the final. And then yeah, that should be, that's the game plan. So yeah, these next 4 days are just going to be Advent of Code, just math study the rest of the thing. Yeah, and there's probably even going to be times where I don't record myself doing discrete math, because I mean the point of these videos is coding, right? But this, at the same time, this isn't just mathematics. it's comp sci discrete mathematics. So like, I mean, there's so many instances of, you know, I mean, this is literally regex, right? I literally said over the winter break I want to learn regex. This is regex theory, right? So yeah. So I will see you tomorrow morning. For this again. So bye.